Alright, today we're going to be talking about probability. So, I'm sorry I couldn't be there with you to go over it, but we're going to get through it pretty quick anyway. Probability isn't very scary, it's not very difficult, so I don't think this will take way too long. So, the first thing that you need to know about probability is the fundamental counting principle. And it's got a really long name, but it's maybe one of the easiest things you ever do in Algebra 2. Let's say you're getting ready for school one day and you have 3 different shirts that you're thinking about wearing, and you can't decide if you're going to wear jeans or shorts, and you've got 3 different pairs of shoes, and you can't decide what to do to make an outfit. How many ways could you dress yourself? Well, you could just list off all the different possibilities, and I wouldn't really wish you to do this more than once, but we could do it one time. It's not a big deal. Let's say you wear the red shirt with jeans and the first pair of shoes. Or then you put on those pair of shoes and you decide, no, I don't like that. So you're going to wear the red shirt with jeans and the second pair of shoes. Or the red shirt with jeans and the third pair of shoes. You get the idea. You could list off all of the different possibilities. Let's say you decide to do the white shirt with jeans and the first pair of shoes. Or the white shirt with jeans and the second pair of shoes. And so on and so on. I mean, you've got all these different possibilities. If you were to keep listing them out, you would end up with, these would cover all of the jean options right here, but then you would still have the short options. So you would have, red shirt with shorts on the first pair of shoes, red shirt with shorts, and the second pair of shoes, the red shirt with shorts on the third. You get the idea. Now, like I said, I don't want you doing this more than one time ever, because this would be really ridiculous to do over and over and over again. It would just be pretty much pointless, especially because the fundamental counting principle is so darn easy. So, blue shirt, pair of shorts, there you go. So, what we end up having here, if you were to add up all the different possibilities, every single last way you could dress yourself, you would be talking about 18 ways of dressing yourself. Let's just type that out. That didn't look so good. Yeah, you would end up with 18 ways to dress yourself. Okay, so that's where we're at right now. Hopefully, like I said, we never do that again. That was a waste of time. That just hurt my head. That was ridiculous. Let's try another example, but let's use some common sense instead. Let's say you have 2 entrees, 2 side dishes, and 3 desserts, and you're deciding what you're going to do as far as dinner is concerned, or lunch, or whatever. It doesn't really matter. Instead of making the big crazy list like last time, instead, let's just take the number of options that we had for each thing and multiply. We had a choice of 2 entrees. We had a choice of 2 side dishes. And we had a choice of 3 desserts. It turns out that's actually what the fundamental counting principle is. Instead of actually having to list out every option, you can just multiply. So in this case, 2 times 2 is 4, 4 times 3 is 12, which means in this example, there are 12 ways that you could choose your meal. If you go back to that first one, it's the same idea because we had 3 different shirts. We had a pair of jeans or shorts, so we had 2 options there. And there were 3 different pairs of shoes. 3 times 2 is 9. Or 3 times 2 is 6. 6 times 3 is 18. So you end up with your 18 ways anyway. So instead of having to list them out, you could just multiply, which saves us a ton of time. So anyway, so that's what it is. That thing is called the fundamental counting principle. So we'll type that in here real quick. The fundamental counting principle. And you can use it when your events are independent, which means choosing one thing has no effect on the other one. So even though it's a crazy sounding name, the method itself is really super easy. You can count your options for each thing, and then when you're done, multiply the numbers. That's it. So it's called the fundamental counting principle, but it's really a piece of cake. Anyway, now sometimes you will see a tree diagram made, and that is actually the same idea. It will still end up with the same number of options. Let's take the shirt example from, or the outfit example from earlier, and let's do a quick tree diagram so I can demonstrate it here. So we had a choice of a red shirt, a white shirt, or a blue shirt. From there, you had a choice of jeans or shorts. So we're drawing out every possibility. So a red shirt with jeans, red shirt with shorts, white shirt with jeans, white shirt with shorts, blue shirt with jeans, blue shirt with shorts. And then we had 3 different shoe options. And I didn't have any special names for the shoes. We're just calling them 1, 2, 3. So it branches out, which is kind of why they call it a tree diagram, because it branches out over and over again. 1, 2, 3, 1, 2, 3. And you just keep going. 1, 2, 3, 1, 2, 3. Hopefully your drawing looks better than mine because I'm using a mouse on a computer, so it's not very good. 1, 2, 3, 1, 2, 3. And if you look at the very end and you count all the branches at the very end, how many branches did we have? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Looks like we had 18 branches at the end, which is exactly the same answer as what we had before. Easy enough, right? So a tree diagram is just another way of illustrating it. So sometimes you will get a test question, hint, hint, where it will give you a tree diagram and it'll ask you how many different options you have. And you just have to look at all the branches at the end and it kind of points you in the right direction. All right, the license plate problem with the really big answer. Arizona decided to change their license plates. In the past, they had 3 letters followed by 3 numbers. How many license plates could be created using this system, and why do you think they changed it? So, old license plates in Arizona went like this. 1, 2, 3, dash 1, 2, 3. It started with 3 letters. How many different letters could you put? Well, last I checked, there are 26 letters in the alphabet. Now, are you allowed to repeat letters? Can you have 2 of the same letter next to each other on a license plate? Of course you can. I've seen that plenty of times. So there are 26 choices for the second one and 26 for the third one. Now, when you're deciding what digit is going to go next, how many different choices do you have for the first digit? Well, it could be 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9, or it could be a 0. That's the one that people usually forget about, is that it could be a 0. So it turns out there are actually 10 different things that this could be, and 10 different things that this could be, and 10 different things that this could be. If you want to know how many different license plates you could make altogether, you multiply all of those numbers together. 26 times 26 times 26 times 10 times 10 times 10, and it turns out you could make 17 million license plates that way. Now, why was that not enough? Well, in Arizona, it used to be, as soon as you got rid of your car, you would get a new car with a new license plate. So there are some people who have had all sorts of different license plates in their life, maybe 5 or 10 or 15 different license plates over the years. So what ended up happening is they ended up running out. I mean, there are, 6, 7 million people in Arizona, so that's not a big surprise. So as soon as they ran out, they had to go to a different system. That's why if you go to California, they have a different system already. They've had it for a long time. New York, same thing, because there are so many people, they run out of license plates. They have to do a new one. So, all right, we're going to move on here. A permutation. So the next word we're talking about is permutations. It's a lot like what we did before, where you just sort of figure out how many options you have for each and then you multiply. You could even just make blanks and line them up. The only difference is in a permutation, the numbers in the blanks go down every time. And that's because the events are dependent. As soon as you've chosen something, you can't choose it again. So here's an example of a situation where you would need to use permutations. In fact, there are 3 of them. Example number 1, let's say a band is playing 3 songs. They're on national television and they get to play 3 songs. How many different ways can they order the songs they choose? They have 5 that are really popular and they can't decide which ones to play, and they can't decide which order to put them in. So, here's the deal. They have 5 choices of song to play first. But as soon as they've played that song, they're not going to play it again. They're on national television. This is their one chance to get their music out. So they're not going to play the same song again, which means when they make their second choice, they only have 4 choices left. And then when they're choosing their third song, they're not going to play any of the first 2, which means now they only have 3 choices left. Okay? And then you would just multiply. 5 times 4 is 20. 20 times 3 is 60. So there are 60 different ways that they can order the songs that they choose. Okay. Sometimes you will see that written as a 5 and a 3 with a big old P in front of it. That is kind of math language for a permutation, and basically it's saying you have 5 items and you are going to choose 3 of them. We'll practice that a little bit more later. How about if 10 people enter an essay contest? How many ways can you choose first, second, and third? Well, any of the 10 people could win. So there are 10 people who could win. But as soon as first place is chosen, that only leaves 9 essays left for second place. Because you can't win first and second. That's just weird. Can't do that. So, as soon as you've chosen second place, now 2 of the essays have been chosen, so there are only 8 choices left for third place. So you end up getting 10 times 9 times 8, so that's going to give you 720 ways that you could do it here. All right, last but not least, how many ways can you rearrange the letters in the word tire? So basically, we're just going to list out all the different ways we could write it. So how about air it, or write, or yeah, I don't know. It doesn't really matter. We're not actually going to rewrite this over and over again. That is going to be really annoying. Instead, we're going to do what we just started doing a second ago. You have 4 different letters you could put first. As soon as you're done choosing that letter, now you only have 3 choices left for the next one. And then you only have 2 choices left for the next one. And then if you've chosen the first 3, you only have 1 letter left. So you put a 1 there. 4 times 3 times 2 times 1. So there are 24 different ways that you could rearrange the letters in the word tire. All right. Now, there is a formula for this. Now, I am not a big fan of the formula, but there is an official math formula that works every single time if you are a formula person. And so if you have a permutation, this is how you would write it. You would, and I already talked about that setup earlier, the number on the left, the little n, is how many items you have to choose from. So in the music example, there were 5 songs that they had to choose from. Now R is how many of those items you are actually choosing. So let's say, like in the music example, out of those 5, they only wanted to play 3. And this weird exclamation point in the formula, some of you have heard of these before. It is called, these are used in what are called factorials. You start at the number, you count down, and when you're done counting down, you multiply. So for instance, if somebody asked you what 6 factorial was, that's the same as 6 times 5 times 4 times 3 times 2 times 1. Okay, that's how factorials work. Or if somebody asked you what 3 factorial was, you would say 3 times 2 times 1. And then you would just multiply it out. So that's why 6 factorial is 720. 3 factorial is only 6. So it changes very quickly. All right, so let's try a problem. This is the last one we're going to do, and we're going to do this problem 2 different ways. 6 people want to run in the senior class election, and there are 4 positions available: president, vice president, treasurer, and secretary. How many different ways can these positions be filled? Well, if we use blanks, there are 4 positions to be filled, so we're going to make 4 blanks. How many people want to run? Well, there are 6 people who might end up being president. Now, you can't be president and vice president. That can't happen. So as soon as president is chosen, there are only 5 people left that could be vice president. And once those 2 are chosen, there are only 4 people who could be treasurer, and then only 3 people who could be secretary. We didn't go all the way down. We didn't make blanks all the way down because there were only 4 positions available. So there were 4 positions, so we made 4 blanks. And there were 6 people to choose from, so we started with 6. You multiply that out, and you get 360 different ways that this could happen. Now, a lot of people are not a big fan of the formula, but that's okay. Let's try the formula out once just so I can prove to you that it works. Now, the formula, in case you didn't know what we were looking for, we were right here. All right, so NPR. So that would be 6P4, or 6 choose 4, as a lot of people in the math world say. And so that means, according to the formula, we're going to do 6 factorial divided by 6 minus 4 factorial. Now, 6 minus 4 is 2, so this is really 6 factorial divided by 2 factorial. All right, so 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, we already talked about it, is 720. 2 factorial is just 2 times 1, so that's just 2. And 720 divided by 2, we are right back to 360 ways, which is exactly what we had when we used the blanks. So it's the exact same thing, there are just 2 ways of doing it. All right, I'll leave you guys to do the last few on your own. It does say for you to try, so let's see how you do with it. And thank you for watching. Hopefully we'll be back for probability 2. Thanks.